use or does not require any UV map channel. In other words, you can just plug your material into any object and it will work. In this category, we can find three methods that we can use. First is the object method, second is the generated method, and third is the camera method. All of these methods can be activated via the shader editor, that is, in the texture coordinate node. So this is the object method, this is the generated method, and this is the camera method. Besides this node, you will also need the mapping node and the image texture node. All of these are very easy to set up if you already have the Node Wrangler add-on. Let's discuss each of the methods one by one. The first is the object method. If you are doing architectural projects, this may be the only method that you will need or use. To use this method, first, you need to plug the object output into the vector input of the mapping node. Then, you may want to change the projection type in the image texture node. By default, it is set to flat. That is the reason why the image is projected in one direction, from positive Z to the negative Z direction. If you look at the bottom surface, you can see how all of the texts are reversed. This is very different compared to the upper part. Again, this is because the image is projected from the top. Before we continue, I think we need to increase the roughness of the material so that we can see the texture better. And also turn off the scene world option so that the background is not too distracting. Or you can also just use the material preview mode, which uses the UV rendering engine. We can see the texture better in this mode. Okay, let's continue with our discussion. Now, if you change the projection type to box, the texture is projected from 6 different directions: top, bottom, right, left, front, and back. That is why, if you look at the cube from any direction, all the texts look normal. None of them are flipped. Besides box, there is also the sphere option. This is like wrapping the cube with paper and then tying up the upper and bottom parts. That is why you can see polar stretching at the top area as well as the bottom area. Usually, you do not want to use this unless the texture you have is intentionally designed to have a polar coordinate. The last one is the tube projection mode, which wraps the texture around just like a tube. You also only want to do this if you have a special texture that is prepared specifically to have the correct width to height ratio. Alright, let me change this to box. The next thing that you may want to change is the mapping type. Please note that this is not mandatory. Personally, I prefer to use the texture mode and not the point mode. Why? Well, we discussed this before, but just to refresh our memory, you see, the point mode actually works in reverse. I mean, large scale values mean smaller texture sizes, while small scale values mean larger texture sizes. To me, this is a bit confusing and less convenient. If you use the texture mode, the scale values you see down here can be aligned with the metric size of the texture, provided that the object is not scaled. This gives another reason why you should always apply the scale after tweaking the dimension values. So, if the object has the default scale values of 1, and you set this to texture, then these scale values are actually equal to a meter. So, the value of 1 means that the projected texture will be exactly 1 meter by 1 meter by 1 meter in size. What we are talking about here is a single tile of the texture, not the whole surface of the object. I think we can see this better if we turn off the tiling. To do that, we can change the repeat option to clip. So again, this single texture size is 1 meter. If we change the scale values to 0.5, then this texture tile size is 50 centimeters square. Now, if we change the scale values to 2, the texture gets cut off. Why is that? The default cube size is 2 meters square, but why does a 2-meter size texture not fit? Well, if you turn on the tiling again, we can see that this is not about fitting the size, but more about the position. By default, the origin point of the object is used as the reference point for the texture placement. If we press Ctrl period and move the origin point around, the texture coordinate will be affected. If you hold Ctrl and snap the origin point to a corner vertex, now we can see the full size of one texture tile. From this example, we can conclude that the projection is not based on a global coordinate, but instead it is based on the object's own or local coordinate. If you rotate the origin, the texture will be rotated as well. For correct results, you should always align the origin orientation with the object's surface orientation. Otherwise, you will get visible squashed or stretched textures. This is something to remember when you are doing a project, especially if part of the buildings are tilted. For example, this is one of my projects, a house design for my client in California, USA. If you have a building like this, and you want to use dynamic projection mapping for the wall material, you do not want to have one object for the whole wall. You want to split the wall in this line. The left part and right part walls should have different origins, each aligned with the direction of the wall. Alright? Now, in some cases, you may want to use the origin point of another object as the reference. Perhaps you want to easily animate the texture or control multiple tilted objects to follow certain object, etc. For this, simply select the object from the list or use the picker icon to pick the object directly in the 3D viewport. Currently, we don't have any other objects, so let's create one, say a UV sphere object. And let's go back to the cube object. Now, we can use the picker icon and click on a sphere object. In this condition, if, for example, we rotate the sphere object, the texture will also rotate. If you want to disconnect the object, simply click on this X button. Okay guys, so that is how you can use the object projection method. The next method is the generated method. Essentially, this is like the object method because it is projected based on a local coordinate and also makes use of the projection type in the image texture node. What makes it different is that the texture size is not fixed. The size is always relative to the bounding box of the object. So you almost always get stretch or squash texture unless you use a perfect cube model. To show you what I mean, if I extrude this part, it looks like the texture is fine. But once we go back to the object mode, the bounding box of the object gets updated and so does the texture size. As you can see, the texture looks so stretched. We can compare this with the object method which has a fixed texture size ratio. Alright? The last one is the camera projection method. Although it is named camera, this mode also works on the active viewport even without the camera. Essentially, it uses the view as the coordinate for the image texture. Usually, you want to use the flat projection for this mode. And let's make the texture bigger to see the effect better. Now, notice as I drag the viewport around, or if I drag the object around, the texture just stays in place as it is now not based on the object, but rather on the view. You may need this projection type for certain visual effects, for example, for making a dimensional portal or the like. Because I mostly work with architectural projects, I rarely need to use this camera projection method.